Good morning. In this particular video, I'm going to solve problems 8.4 to 8.6 of Camel Blau. So as you can see, I'm expending quite some time for chapter 8. Um, my hypothesis is chapter 8 is one of the key chapters of Camel Blau and also of chemical engineering calculation. So, so in my observation, based on the questions in the previous board exams, uh, there are a lot of problems that are similar to the problems that we are solving in chapter 8. So, so my plan is soon we'll have our long quiz. So the long quiz will be coming from chapter 8, and then we'll have our prelims, preliminary exam, and also it will be coming from chapter 8. So what I'm planning to do is I'm going to set a 3-hour schedule, no? Uh, probably probably next week, and then if you are not able to take the long quiz and the prelims on the schedule because of internet problem, there will be another one to be given later before the end of the term. So the same number of hours, probably 3 hours, pero it will be a different set. Okay. So let's try to take a look at the problems. Okay, so this is problem 8.4. So figure 8.4 is a sketch of an artificial kidney. So this is about dialysis. Ano? So remember dialysis? You let the blood flow into the device, and then on the other side of the semi-permeable membrane, you have a dialysate flowing, and generally it's just plain water. So this is a medical device used to remove waste metabolites from your blood in cases of kidney malfunction. The dialyzing fluid passes across a hollow membrane, and the waste is removed in the dialyzing fluid. If the blood entering the unit flows at the rate of 220 ml per minute, and the blood exiting the unit flows at the rate of 215 ml per minute, how much water and urea, the main waste product, pass into the dialysate if the entering concentration of urea is 2.30 milligram per ml and the exit concentration of urea is 1.70 milligram per liter. Okay. Medyo magkaiba yung concentration nila. Yung isa ay milligram per ml, yung isa ay milligram per liter. Is it that just a typo? Mukhang typo lang naman in my solution, I think I use milligram per ml. Yes, that is just a typo. Ano? Yung 1.70 milligram per liter, that is supposed to be 1.70 milligram per ml. Ano? Based on the solutions in the solutions manual. Okay. So if the dialyzing fluid flows into the unit at the rate of 100 ml per minute, what is the concentration of the urea in the dialysate? So how do we plan to solve this? First, how do we solve the amount of water, no, that is transferred or passed into the dialysate? Basically, if you're going to use a basis of 1 minute, so we're just going to subtract 220 and 215. So that means only 5 ml of water per minute passes into the dialysate, no? And then what about the amount of urea that goes into the dialysate? So basically, you're just going to multiply 220 ml times the concentration of 2.3 milligram per ml, and then subtract 215 times 1.70. So the answer to that operation will give you the amount of urea. Yung third question, if the dialyzing fluid flows into the unit at the rate of 100 ml per minute, what is the concentration of the urea in the dialysate? So all you need to do is you need to perform a urea balance. Ano? So that is assuming that the volume of the dialysate is now at 105 ml per minute. Ano? Kasi meron 5 ml ng water na nadagdag. So basically, magbo-volume balance lang muna kayo tapos urea balance. So let's try to solve this problem. So first, I'm going to draw the diagram. So, halimbawa, this is the dialyzer. You have here the blood. No? Goes into the dialyzer. It flows at 220 ml per minute. And then it goes out at a rate of 215 ml per minute. The initial concentration of urea is 2.30 milligram per ml. And then the final concentration of urea in the blood, this is the blood, no, is 1.70 milligram per ml. So if you have the dialysate, it's generally water, flowing at 100 ml per minute. So by inspection, you can say that the dialysate is now at 105 ml per minute. Ano? Kasi if we can see, the blood, no, is reduced by 5 ml. So it's just logical to say that the dialysate increases by 5 ml. So the dialysate flow out of the dialyzer at 105 ml. I hope you get how I came out with this value. And then from the problem, it is also given that you can probably assume that the dialysate initially have no urea, no? So the concentration is 0 milligram per ml. You can assume that, ano? So first let's try to solve the amount of water. So that is simply 220 ml per minute minus 215 ml per minute. So you can say that there are 5 ml per minute of water going into the dialysate. Ano? So this is the answer to the first question. The second question is how much urea goes into the dialysate. So basically that's 220 okay, ml per minute times 2.3 milligram per ml. As you can see, this will cancel out. No, the units will cancel out. Minus 215 again in ml per minute. Then as I was saying before, probably that 1.70 milligram per liter is just a typographical error. Ano? I am just saying that this is a typographical error based on the solution in the solutions manual. Pero syempre, if you're not going to follow the solutions manual answer, you could also use 1.70 milligram per liter, and then you just need to convert this into liter. Kaya lang, the consequences you will have a different answer with the solutions manual. So let's just use 1.70 milligram per liter. So using a calculator, this will give you 141 milligram per minute. This is the same answer. This is urea. The same answer as the solutions manual. And then the final question is, if the dialysing fluid flows into the unit at the rate of 100 ml per minute, what is the concentration of urea in the dialysate? As I've said previously, you just have to perform a urea balance. So urea balance. Okay, so we have 220 ml going into the dialyzer. Halimbawa, base natin is 1 minute, Tapos the concentration is 2.3. And then, yung dialysate, this one, where we assume na wala siyang urea, so 0 milligram per ml. So that will not contribute any urea into the equation. So we have blood at 215 ml going out of the dialyzer. Tapos the concentration is 1.7. Okay. And then we have 105 ml of dialysate. So let X be the concentration in milligram per ml. So upon solving the concentration in the dialysate, .34. Okay. Sorry. 220 times 2.4. It's supposed to be, sorry. Uh, I think that is supposed to be 1,000 ml per minute. Ano? This one, this one. This one is supposed to be 1,000 ml per minute. In the solutions manual, this is 1,000 ml per minute. Ano? So that would be 1,505 yung this one. Magkaiba kasi yung ano no, yung data sa solutions manual at saka yung data dito sa problem. Anyway, so in order for us to get the same answer, I'm going to use 1,000 ml per minute. Okay. So in order for us to have the same answer. Okay. So this is 1,505. So with 1,505, you're supposed to get 0.0934. This will be in milligram per ml. Okay, you can double check the value. 220 times 2.3 minus 215 times 1.7 divided by 1,505. So that will be 0.0934 kilogram per ml. Okay. So we try to make the solutions manual answer and the problem similar to each other. Ano? I hope you. Anyway, if you're going to use the exact number on the problem on Hemmelblau on the book, probably you're going to get a different answer. No? If you're going to compare that with the solutions manual. Pero the process will be the same. Okay. So let's try to solve problem 8.5. So if the last problem is about membrane separation. So the next problem is about evaporator. So this is another unit operation, another equipment in chemical engineering. Usually we use evaporator in sugar industry. So generally we extract the juice of sugar cane, and then we reduce the water content of that juice, not to produce concentrated molasses. And then from the concentrated molasses, we apply crystallization equipment, or centrifugal equipment to produce your sugar crystals. So the equipment that is used to reduce the water content of the sugarcane juice is known as evaporator. Okay. A multiple stage evaporator concentrate a weak sodium hydroxide solution from 3% to 18%, and and process 2 tons of solution per day. So how much product is made per day? How much water is evaporated per day? So let's throw the diagram. So if you have a multiple stage evaporator, so halimbawa you have a 2-stage evaporator system. So generally what happens is, this is your feed, and then some portion of the feed will evaporate. Let's call this B1, and then some portion will become concentrated liquid. Let's call this L1. So what happened is you have another effect. No? So in order for this B1 to be produced, generally we use steam. No? Steam yung pumapasok dito. This is the source of heat. Tapos since multi-stage evaporator nga, you have another effect. You have another evaporator. So what happened is that this L1 enters the second effect, and you produce the final product. No, let's call that L. And then basically what in order to save an energy or make the process more efficient, we use the B1 as the source of heat in the second effect. So parang ito na yung magiging steam, So dito. Okay? So you're going to produce another B here. No? Of course, this looks complicated, pero for your to simplify this, basically the process is you have a feed, tapos some water evaporate from the feed, so we call that vapor, and then we produce the product, the concentrated liquid. Ganito lang yan, no? So these two are just similar. Ito usually ano na naman to pag nag-bus balance naman tayo, hindi na to kumbaga this B1, this B2, so this B1 and B2 is actually equal to B. Ganun lamang yung nangyari dyan. Pero at this moment, you should not be concerned with this. You should not let this complicate the solution process. Because at this point, parang it's just similar. No, it's quite similar to a drying process. We're just removing water. So B here is 100% water now. Okay. So F is equals to 2 tons per day. And then it's initially, the sodium hydroxide concentration is 3%. As you can see later, we're going to perform sodium hydroxide balance. Ano? Remember, this is 100% water. So this is 0% sodium hydroxide. This be over here. Diba? And then this is 18% sodium hydroxide. Okay, so as you can see, there are only two unknowns, B and L. And then you are asked how much product is made per day. This is basically L. That's basically L. Ano? How much water is evaporated per day? That is B. Okay, so it's just a simple overall mass balance, then sodium hydroxide balance, and then solve for B and L. Okay, so this is the evaporator process. Ano? Overall mass balance. So that would be F is equals to L plus B. And then F is, halimbawa, ang basis natin is 2 tons. Ang basis natin is 1 day. So that would be 2 tons. Tapos L plus B. And then we perform sodium hydroxide balance. That would be 2 tons times 0.03. L times 0.18. And then this one contains no sodium hydroxide. Ano? So as you can see, you can solve L using the sodium hydroxide balance. That would be 2 times 0.03 divided by 0.18. That would be 1/3. Ano? So this is 1/3 or 0.33 tons. So, pag binalik ko dito sa first equation, yung value na 1/3, di ba? You can find out that B is equals to 1.67 ton. Okay, so these two are the answers. Ito yung water. Ito yung liquid product. Okay, so let's go to the next problem. So this is problem 8.6. Ano the last problem? a liquid adhesive consists of a polymer dissolved in a solvent. Ganyan lang naman yung sistema ng ng pandikit. Meron polymer solution lang yun. The amount of polymer in the solution is important to the application. Kino-control yung concentration ng polymer. An adhesive dealer receives an order for 3,000 pounds of an adhesive solution containing 13% polymer by weight. On hand is 500 pounds of 10% solution and very large quantities of 20% solution and pure solvent. Okay, so you need to calculate, this is the question, you need to calculate the weight of each that must be blended together to fill this order. Use all of the 10% solution. So, yung importante dito is that you need to draw the diagram correctly. So, if you will imagine it, isa lang naman yung gusto nating maging product, no? Yung order na 3,000 pounds, tapos 13% yung kanyang concentration. Pero marami tayong inputs. So, yung inputs natin yung 10% solution, lahat daw yung gagamitin natin. So, 500 pounds of 10% solution. 20% solution, at saka yung solvent. So, tatlo yung input natin. Isa lang yung output natin. I hope you can picture that out. Let's draw the diagram. So, tatlong input. Ito yung 500 pounds. Tapos ang concentration niya ay 10%. Tapos yung isa, solvent. Yung solvent, ang concentration nito ay 0%. Tapos 0% polymer, ano? This is polymer. Puro polymer. Siyempre, ito pure solvent. Ano? This is your solvent. And then we have the 20% solution. So let's call this your feed, no? 20%. Hindi natin alam kung gaano karami yung F in feed natin. And then we have the product. So the product is 3,000 pounds. Tapos the concentration is 13%. So as you can see, we have only two unknowns, ano, F at saka S. So, tapos two equation, the usual equation, overall mass balance and polymer balance, and you should be able to solve F and S. So F and S lang naman yung kailangan natin i-solve. Okay? So, let's do that. First, let's perform the overall mass balance. So the overall mass balance equation will give you 500 pounds. Tapos plus F plus S. And then it should be equal to 3,000 pounds. Tapos let's perform a polymer balance. So the polymer balance is 500 times 10% plus F times 20%. Yung S, this contains no polymer, so it's not included in the equation. And then you have 3,000 pounds of product times 13%. You'll be able to calculate F. You're supposed to get 1,700 pounds. Ano? So F is 1,700 pounds. Okay. This is the 20% solution. So if you're going to substitute the 1,700 pounds right here on the overall mass balance equation, you're going to get 3,000 minus 500 minus 1,700. 800. So solvent, this amount of solvent is 800 pounds. So 1,700 and 800. Okay, so that checks out with the solutions manual. So I suggest you try to solve all the problem in chapter 8. It will not take very much time. It's essential in your understanding of chemical engineering calculation. And also, I think it's also essential for you to have a very good score in the coming long quiz and prelims. And then don't worry about the exam. It will be, I think it would be easy. Tsaka wala namang, there's no failing grade this term. So Just don't be anxious, no? Just relax. Enjoy solving problems in hand with love. Okay? So probably in my next video, I'm going to tackle the next chapter. And I'm also going to announce the exam later. Soon. Okay, so see you in the next video.